Hello friends, welcome back to another session. In the last session we have completed we cannot say that it is completed some more topics we have to see in a Spring Boot, but we will see when in the upcoming session that also. So in the last session we have seen only so far Spring, why we need a Spring Boot, how to configure the Spring Boot properties in property file, how to add the Spring Boot starter to resolve the dependency and to avoid the dependency version automatically, and we have set up the Spring Boot plugin in our Eclipse IDE so that we can run it very fastly, and in single panel we can run the application and we can execute them. So now we will start RabbitMQ, because RabbitMQ is also used in microservice architecture. RabbitMQ, Kafka, these two are a message broker, and as we know now the application development model is switched from monolithical to microservice architecture. In monolithical, all the whole application code will be written in a single project, and it will be compiled and built and will be deployed to some server. But in microservice architecture, approach is somewhat different. So in the upcoming sessions we will start microservice also, and Spring security microservice we will do. So first we should before to start microservice also we need to understand what is RabbitMQ and Kafka. So first we will learn RabbitMQ, then we will learn Kafka. After that one, some topic I think almost completed in Spring Boot, but if still some topic is remaining, we will see that also. Okay, before to start microservice and Spring security. So please keep watching and supporting us for the upcoming sessions. Okay, so let's come to the today's topic. What is RabbitMQ and why this RabbitMQ is required? So RabbitMQ is an open source message broker and message broker software, and it is written in Erlang. Erlang is a programming language, or you can say Erlang or Erlang, whatever you are comfortable to pronounce it, you pronounce it. So RabbitMQ is an open source message broker. What is message broker? We'll see. And RabbitMQ is the implementation of AMQP protocol. What is AMQP protocol? It's an advanced messaging queuing protocol, same as similar to HTTP, but HTTP protocol goal is somewhat different. HTTP means hypertext transfer protocol. We have to transfer the data in HTTP format. Advanced message queuing protocol, this is just to send the message simply. It is, you can say, it is like a postman. Suppose I have to send some message to some person and I don't want response immediately. Suppose I want to send some letter to my relative that is staying far from me in another city or in another state or in another country. So the one way I can directly call them in the phone and I will give the message and immediately I will get the response. Yeah, I will get the immediate acknowledgement, yeah, I got this message, and yeah, that is okay. Other way, I can send them a post letter using some posting services like Indian Post, Bharatiya Dak. You can say Bharatiya Dak, that is a better word to say. So what will happen in this case? If I send a post letter to my relative, I have to give the address. This is so and so is the address, and please send the message to that person. But I don't want immediate response. Will you expecting the immediate response? No, it will not come. It depends how far it is. It may take some time if the route is already busy, so many other work is there, so many other post is pending still. So first that has to go, and then your message will be delivered. Definitely it will be delivered. It might take some time, and it might get immediately executed. So the same scenario is happening in RabbitMQ also. That is also a message broker only, similar to Postman. So why this is required? Why this is required? Why it is required? Suppose you have visited some of the e-commerce website like Flipkart or Amazon or any other. You have selected some item and you placed your order. So simply when you are clicking on place order, what you are doing, you are going to payment, and just after payment you are just your order is placed. What is happening after your order is placing? Whether it is immediately placed the order, or it is went to your queue, you don't know, and you are not, that is not your concern also whether it is placed or not. Your just one message will be displayed in your screen: thank you, your order has been placed. Simple. Whether what is happened in back end, is it happening immediately when you are clicked on the place order button, or later on it is going, you also don't need to know that one. So in this scenario where you don't want immediate response, you can use any message broker in your application, so that it will increase your application performance in terms of the request and response time, because that not at all is required. Whether you will be updating some inventory, you are updating your order to so and so on team, and then team is processing, that step can happen later also. Once your message should be ready in the queue, so that from the queue they will pick later on. Automatically your system will pick. It might take 1 day, 2 day, 3 day, depends on your configuration. Just your concern is to just place order. What need to happen, that is for that much time it has to insert into some table. When you place the order, record has to be inserted in your some table, and some tables data has to be updated in other service also, and that data has to send to your order management team, so that order management team will pick your order and will send to the vendor, and the vendor will prepare the item and will send to the consumer. So that process is time taking. You should, it is not like that you are waiting in front of your system and you are waiting for the response, when it will be placed. They will just show you one message, your order is placed, that's it, your job is done. You can shut down your system, sign out, and you can do your work. They are slowly processing your order and doing the further task. So that is called message broker, where you don't want the immediate response. So now just read the definition also. What is message broker? A message broker, also known as integration broker or interface engine is an immediately computer program module that translate a message from formal messaging protocol of a sender to a formal messaging protocol of a sender to formal message protocol of the receiver. Okay, message broker are elements in telecommunications or computer network where software application communicate by exchanging formally defined message. So message structure you can decide any of type. It can be simple string, this can be a XML, this can be a JSON object, any other, whatever format you can define the message format. Okay, a message broker is a software that enable applications, systems and service to communicate with each other and exchange information. The message broker does this by translating a message between formal messaging protocol. This allow interdependency services to talk with another directly, even if they are written in a different language, or implemented in a different platform, doesn't matter. This is the best advantage that we are getting in RabbitMQ. That might be written in another language also, you can use. Now for asynchronous communication, we can say that also message broker sends the message in asynchronous manner, we can say like that also. Now what is asynchronous messaging? What is synchronous messaging? First, HTTP message is asynchronous because whenever you are calling to some service, suppose if you go to your Flipkart and you are telling show my order, you want to show the list of order that you placed in your past, so you want that order detail immediately. So immediately if you want, then that is a synchronous communication, and you say please give me the order list, but you can say yeah, you can send me that later also through mail or through phone or something like that. So that is asynchronous communication, means you just informed to some person, the person will grab the detail, or you have to send some message to some person, you have informed that message to some person, and that person will and your job is over, that person will inform, might be later on or immediately, you don't know. Whenever that person will deliver the message, the person will inform you, yeah, I have delivered, and your job is to give the confirmation. That's it, yeah, it's delivered, that is okay. So that is asynchronous communication. Refer to the type of inter-application communication. Inter-application means two application has to communicate, that message brokers make possible to intercommunication. It prevent the loss of valuable data, like if you sending a message in form of HTTP, that there is a chances the data may loss. How? Suppose the server is not available, it will give you error, you have to send that message again. It is not like that in HTTP you have sent a message and your server is down. If your server is down, your message will not go, you have to send the message again. But if you are using message broker, even if your receiver server is down, it is not up, later on whenever the person will come up, he will receive the message. Okay, so it prevent the loss of valuable data and enable system to continue functioning even in the face of intermediate connectivity or latency issue. What is latency issue? Sometimes server may be down, no, so that is a latency issue, it has to down. Or sometime what happens, network is so busy, in that case also it will try for some time, and if it is not getting any response from the network, will tie down the connection. In that case also you will lose your connection. But in case of broker, messaging broker, definitely it will deliver the message. It might take some time, even it will take 1 day, 2 days, 7 days also. It will keep that message in your in the message broker, in the server only. Even the server, if you tear down the server, message broker server also, you shut down the message broker server also, then also the message broker will keep that message in queue. Whenever you start the server, it will the message will be ready in the queue. Whenever listener is ready to listen, it will send the message. So it is 100% guarantee that your data will be delivered. But in HTTP, if server is not down, server is not up, server is down, it will fail. You have to send message again, it will not save message anywhere. So this is the asynchronous communication. Asynchronous messaging guarantee that message will be delivered once and once only. Only one time you can deliver the message, but it will be delivered in the correct order related to the other messaging. Whoever come fast, it will give that one. Message brokers may comprise queue managers to handle the interaction between multiple messaging queue, as well as service providing data routing, messaging translations, persistence, and client state management functionality. Okay, now what is asynchronous communication? We have already read about this one. Asynchronous programming is a technique that enable your program to start a potential long running task and still to be able to be responsive to other event while that task run, rather than having to wait until the task has finished. Suppose you are placing order, same scenario, you are placing your order, but while placing the order, it is saving in the database, then it is updating to the teams who is managing the order. From that one, saving in their data, then we are getting the response and we are informing to the user that yeah, your order is placed. But that process is not at all required. You can do that process in your system later on also, whenever the traffic is low, there is no much traffic, you can do. So in that case you can use asynchronous communication. So once the task has finished, your program is presented with the result. Asynchronous communication, called offline communication also. This is called offline communication also. Synchronous communication called online communication. Asynchronous communication called offline communication. Okay, what is synchronous communication? It's completely opposite to asynchronous, where you want response back immediately. This task that are no longer running and can be done faster and return the response back to user, called synchronous communication. Okay, so this is all about the message broker. Okay, and message broker has a protocol name that is called AMQP. RabbitMQ is the implementation of AMQP, Advanced Messaging Queuing Protocol. Kafka is also AMQP. Kafka is also implementing AMQP protocol. Okay. So RabbitMQ is the one implementation of AMQP protocol, and Kafka is another implementation. So we will learn both. First we will learn RabbitMQ, then we will learn Kafka. And Kafka and RabbitMQ are message broker. What is message broker? We will we have learned here, sorry, we have learned here already. Now we'll see some definitions of RabbitMQ. RabbitMQ is most widely deployed open source messaging broker. Okay, we know what is message broker, what is open source, we know. Okay, RabbitMQ is message broker that implements AMQP, advanced message queuing protocol. Okay, AMQP stands for standardized messaging and using producer, broker and consumer. Who is producer? The sender. Sender is a producer. Who is broker? Who will send or who will deliver the message, and who is consumer? Who will receive the message. Suppose I have to send a message to my relatives, so I am the producer, postman is a broker, and my relatives, your mama, chacha, that is a consumer. Okay, RabbitMQ increase loose coupling and scalability. Loose coupling, like will not be relying on the technologies. You can consumer can be others, producer can also be others, no issue. Okay, so simple system. If you understand the concept little bit here, suppose I am the producer, I want to send a message to my relatives, so I have to send that, I have to tell that message to broker. Now broker is which one? Broker has this exchange, broker has an exchange where we will send the message. So exchange, from the exchange it will be, there can be one or more queues, one queue or more queue it can have. So your message will be placed from exchange to queue. Producer will send a message to broker. Broker is nothing but this exchange and queue is the part of broker. Exchange and queue is the part of broker. So first broker will, so you will push the message to broker, broker will send the message to exchange. From exchange it will go to the queue, and inside queue there may be 1 or 2, 3, 5 n number of messages that is already waiting to send. First that message will go, then your message, then your message. So in that case it may take time. It may go now only, or it may go after some time, or it may go after some days. It depends on the availability of consumer. Whenever the consumer will be available, or whenever consumer will be able to consume the message will go. If consumer is not ready at that time, or if consumer has a more burden or more loads or some network congestion, in that case the message will sit in the queue only. Your message will be added in queue, and then from the queue it will be go to consumer. This is a simple system. So producer publish a message to exchange with the routing key. Now routing key, what is routing key here? Suppose here, if you see this diagram, there is only one queue. There can be multiple queue also. One exchange can be binded to multiple queue. So you need to tell to which queue. So produce routing key is nothing but a key that is binded with that is binding between exchange and queue. So that is a routing key. Okay, exchange connects to queue with the binding key, and then the message will be distributed to queue. And consumer consume the message from the queue. Okay, so if you see the complex system, so this is a complex system. Your producer will send a message to broker. Broker will send the message to exchange. Now you have to tell exchange is binded with so many queues, 1, 2, 3, 4, 10, 100 queue. There can be 100 queues that is mapped to a particular exchange. So you have to tell which queue I have to deliver the message. So producer has to tell what is the queue name, or you can say what is the ID that is binded to this queue. So that is nothing but routing key. So a producer will say, yeah, this is the routing key, send it to this exchange, this is my exchange and this is routing, and along with the message. So your exchange will transfer the message to queue. From that one, whenever consumer will be available, will consume that message. So this is complex system. So producer publish a message to exchange with the routing key. Exchange connects to queue with the binding key, and then the message will be distributed to all the matching queue. Wherever, suppose the same queue, this and this queue, both queue are binded with the same routing key, so the message will go to the both. If it is a unique, it will go to unique. It's up to your choice how you want to define. Message distribution from exchange to queue is depending on the type of exchange. Now exchange has some type in RabbitMQ. This exchange has a type, this exchange, you see. So 4 types of exchange are there in the RabbitMQ: direct exchange, fan out exchange, topic exchange and header exchange. So what is direct exchange? It route message to a queue by matching a routing key equal to binding key. Suppose you are giving exchange name plus routing key, so message will be sent to the exact routing key that is mapped with, or that is binded with the exchange, exact that only. And in case of fan out, you no need to send the binding key. It will automatically, the message will be sending to all the queues. Exchange will send the message to all the queue. This queue. Whoever is consumer is consuming this message will get the message and will start consuming. So fan out means you no need to send any routing key, or to all the queues the message will go. But in case of direct exchange, it will go to the particular exchange only. Topic exchange, it route message to multiple queue by partially matching the routing key. It will match the pattern, and wherever the pattern is matching, will send. It use a pattern to match the routing key and binding. We will see through example, then you will understand how it is. We will see the we'll have to install the RabbitMQ server, then we have to write our code in our Java program, and then we will create the exchange. We will see how we can do it. Header exchange is used message header instead of routing key. So in header we will send some name, and that name will be sent to with the queue, and it will automatically take whether if this is a header, then go to this message, this queue, like that. Okay. Now there is some basic concept of RabbitMQ. We will see that one. What is producer? The sender is a producer. A producer is one who send message to a queue based on the queue name, is a producer. What is queue? A queue is a sequential data structure that is a medium through which message is transferred and stored. So a queue is a sequential data structure, or a data structure where all the message will be added, and whatever message is coming first, that first will be sent to consumer. So that is queue. And consumer is the one who subscribe and receive message from the queue. So consumer is nothing but the receiver who get the message from the queue, from the broker, and use that message for other defined operations. Okay, yeah, the operation, that is the responsibility of consumer. What operation you want to apply on the message? Message is nothing but it's a data. It's a data that can be in JSON, string, XML, whatever type of message it will be. It will be a data only. So what operation you want to perform on the data? If you want to store that data in a database, you can do so. If you want do some statistic operation on that one, you can do whatever according to the business requirement. You can perform any operation on the data at consumer side. Okay, exchange is the entry point of a broker, where broker will send your message, because it take message from publisher and route those message to appropriate queue on the basis of routing key, or if it is a and exchange has a types also. I have seen now exchange can be a fan out exchange, direct exchange, header exchange. Okay, so that if it is any type of exchange, it depends on a type of exchange, and according to the exchange it will route the message to queue. Okay, bro. Fine. Broker who provides storage for the data produced. So the data that is stored, broker will keep that message with itself only until the consumer is not ready to accept that one. Okay, the data is meant to be consumed or received by another application that connects to the broker with the given parameter or connection string. And a channel offer a lightweight connections to a broker via a shared TCP connection. Okay, so this is the definition of RabbitMQ. What is RabbitMQ? Why need a RabbitMQ? RabbitMQ is a message broker that is written in Erlang or Erlang, and this is the implementation of AMQP protocol. Okay, and for asynchronous communication we have to use a message broker. Message broker can be anything. It can be a Kafka or it can be a RabbitMQ. RabbitMQ and Kafka both are the implementation of AMQP protocol. Okay, so this is all about the RabbitMQ. In the next session we will see the installation, how we can install the RabbitMQ in our local machine. Then we will start our coding side and we will learn this by doing some labs. And if you found our material is useful, that please make your financial support to us. You can use any of the method, or you can scan this QR code and you can do your contribution for us, or else if you want to transfer via bank, you can do that also. So that's all about in today's session. In the next session we will see the installation of RabbitMQ and we will do some coding labs. In upcoming labs we will learn the entire RabbitMQ. Okay, thank you and have a nice day.